Modeling, Topic 17, Delta Hedging. Section 6, Simulating Delta Hedging for a Long Call. So we're going to take our model we built last time, and instead of using the actual Google prices over those 13 days, I want to simulate Google prices using our risk-neutral stock sim function we developed in the last topics. That requires the initial stock price, the interest rate, the dividend yield, the volatility. Now the V, that's going to be what I expect the realized annualized volatility to be. My T, since I'm going to do a simulation of daily stock prices, my T is going to be 1 over 252 for a one-day simulation of the stock price every day. And lastly, that Z is going to be a random variable, my standard normal random number, using at risk, that's risk normal 01, using a macro worksheet simulation. I'm going to use norm S inverse rand, but we're going to use at risk for this one. So let's go to our spreadsheet. I have the same spreadsheet, and all I need to do is put an at risk functions in there and add my simulation. So let's do the simulation first. Let's use that random walk model. I'm going to insert a function. I've already copied into my workbook called risk neutral stock sim. I'm going to put in the initial stock price, and my initial stock price here is 614. I'm not going to anchor that. I'm going to anchor the interest rate, 10 basis point, dividend yield, 0, volatility. This is going to be my forecasted volatility. Let's use 18.67% for this one, anchor that. The T, let's make that 1 over 252. I want to just simulate one day's stock price. My Z, I'm going to reference this cell right here. Because I have at risk running, I can put in a random Z variable here using at risk equals risk normal 01. I'll copy that down. So risk normal 01s. And then I'll copy down this formula here. So now I have 13 simulated prices based on 13 random Z's, which at risk is going to simulate. I'm going to then sum up that profit, say 10,000 times. So I'm going to go to at risk. I'm going to make that profit and do add output and hit OK. I'm going to make actually the standard deviation an output, add output, OK. And then when I want to collect from at risk, because I want to collect the mean of those 10,000 possible P&Ls. So I'm going to say equals risk mean, open, click on that output and close, and do the same for this. I'll return that one back to a percent. Okay, so now I'm ready to run at risk. I've got 13 random inputs. I've got 2 outputs. And by the way, since I haven't mentioned this before, notice I use BS call to value the option every day. When you do that, you need to make sure that last value is not BS call. That last value is the payoff of the option at maturity. So for a call, that's max 0. ST minus the strike. I'll then run at risk. I'm going to click on my P&L and I'm going to run at risk, and I'll talk why it's running. So I'm going to do 10,000 iterations and go. So here's what I expect to happen. Since I'm modeling these prices based on based on a realized vol of 18.67, and that is my implied vol. If the realized vol is equal to implied vol, I expect the option to break even, have zero. The delta hedge profits to be 0. So what I expect is after these 10,000 iterations are done, and I look at the distribution and calculate the mean right here, I'd expect that mean P&L to be very close to 0, because the realized vol, I'm modeling it as if it is equal to the implied. So let's watch this for a minute and wait for it to finish. There we go. The simulation's done. And what we see is the mean of this distribution of P&Ls. It looks like it's centered around 0. And in fact, the mean is negative 80 cents. Now my 90% confidence interval are the P&Ls between negative 394 and positive 393. So my mean distribution actually finished up there about negative 60 cents. In theory, it should have been about 0. Now, in theory, when I was thinking about doing this trade, I thought implied vols were going to be about 23%. So I was actually hoping when I valued the option, putting 23% in, I got a Black-Scholes price of $12. When I saw this $10 option, I thought, wow, that looks cheap. And if I take the difference between $10 and what I valued it at using my volatility estimate, I thought I'd make the difference between 1246 and 1005 times 100 shares. That's 241. Now, if I rerun the simulation based on an actual vol or realized vol of 23%, I get a P&L really close to my estimate. So I'm not going to run that again, but when you run that based on a realized vol of 23%, which affects this, what you see is the mean turns out to be about 241. So that was what I was hoping when I put on this trade. So in this topic, we simulated delta hedging for a long call.